Cool. Let's do this.
Right. Thermodynamic assessment of algal biodiesel utilization, which I think is a great title.
What does
But,
that even mean?
um, basically judging whether or not the production and use of algal biodiesel actually is useful, as in, does it produce more energy than it takes to produce it? Uh,
Cool.
yeah, the thermodynamics obviously energy, and then it's just reviewing the standard process that is used for biofuel production in general, and specifically with algae. So, uh, I'm gonna start with the method that they used for production for the growth of the algae first. Yes, so in the paper, they grew the algae in a large glass covered pond that they kept pressurized in a CO2 environment and filled with a bunch of salts specifically for growing the algae. The pressurized environment had an off valve where, as the algae matured and sunk to the bottom, it came out of the valve and went into a continuous processing system where they dehydrated the algae and they used ethanol to separate off the lipids from the rest of the biomass of the algae.
Quick comment here. Does anyone else notice that this paper has an actual nomenclature section? Because that shit's cool. Like,
Yeah.
how often do you read a paper and it also says, and by the way, we called something F and you should just know what F is? This is awesome.
They missed out a few things from it, but generally it's good.
All right, please,
so
as
many
you were.
equations. There's so many equations in this paper. There's so much maths that they did. They have tracked.
Right, because it's thermodynamics, right?
Yeah.
Yeah.
They have tracked the energy input and temperature of every single piece of equipment and all of the different things that they are putting through the process. It is
That's so
incredibly in depth.
satisfying.
It's great. Is a whole section on when they're mixing catalysts in, and they describe different mixing methods and how effectively it utilizes the energy put into the mixing method to mix a catalyst with a solvent. This paper is great. It's so in depth. But yeah. So the general layout was they had a glass covered pond, and that was pressurized with CO2, so that CO2 dissolved in the water for the algae to process. There's the off valve where matured algae come out and go into a vat of, I believe they were using ethanol, or to dissolve out the lipids. This was then mixed with, what was the catalyst? They mix it with a catalyst of sodium ethanolate, with more ethanol. And then left it with the lipids for an hour, and that was all the processing they took to actually get it to convert the lipids into a biodiesel. Then they just separate out the biodiesel and separate off. Then they separate out the biodiesel and separate the ethanol out from the catalyst as much as they can. And it yields a 98% yield of lipids to biodiesel, with a 2% of glycerol coming out as well. Oh,
Is it very pure? Like is it easy to? Does it have many contaminants besides the glycerol? Is it very easy to separate them out of it?
They separated it solely from the fact that glycerol and biodiesel don't mix.
Okay.
And I think it was the glycerol was heavier.
Okay, so
they just skimmed the biodiesel off the top.
Also, I think there's some text. It's not actually part of figure 2. I'm just using it because that's the easy reference point. But underneath, Figure 2, it's like the composition of a cell is, and then it's like, I don't know, basically a monologue from Full Metal Alchemist. And then they're like, and then according to this, and so then they're like, okay, so this is what it is. And so they actually have an equation where they're kind of hammering that shit out as well.
Yeah.
Correct?
Yes. All of the elemental makeup of the cells, and then they use that to determine all the salts that they want to dissolve in the pond to have optimal algae growth, which per 72 kilograms of water they decided is 2 kilograms of COOH2 to 6 kilograms of KCl, because I don't know what the names are, 1 kilogram of, yeah, it's all just listed out in the second paragraph, in the paragraph just under the 9 for the equation. But yeah, they have gone truly in depth in every aspect.
Does that answer the question asked?
Yeah, I think so.
And for those of you just joining in, the paper is tagged in Journal Club. We don't got slides. You're just going to have to follow along like a normal human.
Yeah, we're currently on page 4 because I'm speeding through because we're going to be backtracking on it anyway, regardless for questions. Yeah. So the biodiesel is produced via mixing a catalyst with ethanol and leaving it to sit for an hour. You can, depending, or it doesn't have to be ethanol, can be any alcohol. Ethanol, I believe they had to heat it to 50 something degrees. If they used methanol, well, it could do it at room temperature. Other alcohols take longer. And then,
this is all centigrade, right?
Yeah, centigrade. I can't do Fahrenheit. I have no idea what that would be in Fahrenheit. Other than over 100.
You gotta go back and forth, man. Anyhow, go ahead.
Yeah. Then they measured the energy it takes to separate out the glycerol from the biodiesel, or separate out the catalyst from the ethanol, and separate out some minor excess water from the ethanol from the biodiesel as well. They added in extra ethanol to increase the reaction time as it is reacting with ethanol. And if we go to, which page was it? Page all the way over to page 9, after they have done all of their maths, you can find that you find the useful exergy produced from the process for algal biofuels is 40 gigajoules per ton, which compared to standard diesel, which is 47 gigajoules, and gasoline, which is 46.9 gigajoules, is actually pretty comparable. So that is, exergy is the energy output minus the energy it takes to produce it. So in the case of diesel and gasoline, that is the energy required to get it out of the ground and separate it out into the diesel and the gasoline. For us, it's the whole growth and refinement from lipids to biodiesel. There's actually a very close amount of energy that you get from this process. And comparing it with cooking oil, which generally comes from plants, which only has 31 gigajoules. So this is shown to be a really effective process for producing energy. And the energy, what was it called? Renewable indicator factor, which is the ratio of exergy to total energy of the fuel, was found to be 0.27. So just over 3/4 of the energy was used to produce it and is produced, which leaves a lot of room for refining that down, as they have said, using other energy sources that are intermittent in order to produce this, or genetically engineering algae to produce more lipids so you get more throughput and more production. That is the very quick overview, because I was not expecting to get through that in 10 minutes.
Yeah, actually too much.
Yeah, that was a lot of talking. I'm certain people have to have questions.
Yeah. So I'm still kind of reading this, and I'm curious. When they're doing like the full breakdown of how much a thing costs, is it also showing the, like, so for instance, they're using ethanol as a solvent,
Hmm.
right?
Yes.
Is the production of the ethanol calculated into this thing?
I do not believe they accounted for that, no. Because for the most part, the ethanol is not actually used up. A very small percentage of it is, but a lot of it is recycled constantly through the process.
Yeah, it's a catalyst, right?
No,
Right, but
the catalyst
no,
was sodium ethanolate. Ethanol was a solvent to dissolve the catalyst and lipids in.
great, but ethanol is like hella volatile, especially when heated. So yeah, I just wanted to double check that. I was curious.
They didn't account for that solely because, in theory, you could have a system that doesn't lose any ethanol. And as this is thermodynamics and not practical engineering, they are working in theory using some measurements.
Some sort of spherical lipid.
Some idealized system where they make some assumptions. But if they were to account that the cost for producing all of the ethanol, it would be an incredibly inefficient system. So they've gone with none because it's closer to none. I think, what was it? They used 268 kilograms. I checked my notes. I believe that's what they used. Yeah.
So I have a random
258.
question.
And they
that's
only
kind
used
of
0.6.
outside.
Yes.
Yeah, I have a random question that's like totally outside the scope of this paper, but it looks like this came out like this was part of a textbook from like the 50s to 60s, and so we're not really like using this, it seems like.
To my understanding, there was several companies that do algal biofuel production, but no one's made it profitable.
I was looking at the page number. I'm sorry, I looked at the page number. I thought it was the year. My bad.
No, this came out in 2010.
Yeah, they mentioned 2002. If it was in 66, well.
Yeah. There was a lot of papers coming.
Yeah. However, even 2010 at this point in time, I don't know if we'd consider this state of the art, but it is really useful for primary papers in as much as that's where this technology comes from.
It's kind of dated, this 81% of fossil fuels, even for 2010. I believe we had better, we were better at 2010 by comparison to 2002. Many countries have changed their base energy source from fossil fuels. So
a lot, but there's still an absolute crap ton that are utilizing fossil fuels and combustion in general, and then planes are still using almost entirely combustion.
Yeah, and it's hard to change that.
Yeah, whereas if you can have a if you can have a fuel that is produced in a carbon negative manner and doesn't require you to change all of your engines and all of your generators over, that can be accepted quite readily.
Yeah,
is that like achievable?
I was wondering. I mean, is this fuel you like? Can you use it in like existing kind of systems? Like,
I mean, you can literally take kitchen oil and put it in a diesel engine.
Right.
This is correct.
Like
you'll go to jail for it in Germany, and in England it's kind of encouraged. So yeah, it's we live in a society.
Okay, so my I'm gonna try to just hammer through this. One of these concepts is violating the laws of thermodynamics. And so, we can show that how we can be better at doing things, but we have to understand that the concept of being like negative energy expenditure to meet energy needs isn't technically possible because thermodynamics is a thing. But Also, weren't you going to go back and like hammer out some more details on this paper?
Only if people had questions for it, because I don't know what people don't do and don't know.
I'm a little confused here. How do we violate the law of thermodynamics?
No, as in a lot of people look for energy sources that seem to violate the laws of thermodynamics.
Free energy.
Okay.
Yeah.
It makes you feel good.
Say, I don't think it's possible to violate such a law.
No,
right.
But that's the point of these sorts of papers.
My point
is to know, does this source actually produce usable energy according to thermodynamics? Because if this comes up as you can't produce usable energy from thermodynamics, there would be no point in pursuing it further.
I think my 5 cents would be like on the note of carbon negative combustion. I think it's the fact of growing that algae, which is already carbon negative because you have sequestration, and then combustion. Like if you know about complete and incomplete combustion, like biodiesel has the most complete combustion. That means like completely CO2 instead of carbon monoxide and so on. So I think that net input is carbon negative, sort of like as we spoke. I spoke to Ali about this.
Yeah.
So that's how it
so
works.
Like,
it's not really.
Yeah, if you go back to
solar produced diesel fuel, basically.
Pretty much, yeah.
Yeah.
If you go back to page 4, you will actually see like it's listing out the composition of bacterial cells. 50% of the element in it is carbon. And since it's only about 20% into or so that's coming out of the cells as lipids, it's still keeping an absolute crap ton of carbon out of the atmosphere, even if you're burning things again.
Mm-hmm.
Exactly, yeah. Because plants have a hard time sequestrating carbon monoxide and also like all kinds of other like triple bonded carbon, for example. Like it's easier for plants to just
And plants
there's this concept that we use in laboratory talk about normalizing against the control. And so like just the concept of what is negative is explicitly like that means you have to set a baseline. And so we already have a baseline. We already have like a place where we're doing the things normally. And so negative in this concept means below the baseline that we have established, not in like a true absolute zero physics level of negative.
No, right. Like we take into account the whole cycle. Yeah.
But if we compare no cars at all to cars running off of algal biofuels, you are actually still reducing carbon in the atmosphere.
Yep.
Which is what I was trying to get at.
Which is amazing.
Yeah, let's go forth. Carry on.
Well, I love this paper. Does anyone else have any questions?
Yeah, I'm a little bit curious, like, what has spawned out of this work? So it's a cool paper, and I'm happy we're talking about it. It seems really interesting, but like, has anyone worked with it thus far? Like, are these profs?
I mean, there are companies that are
doing anything with this, or these research?
There's companies doing in algal biofuels, and there is a whole folder in the to be sorted one just labeled algal biofuel.
Oh, okay, cool.
Actually, no, I think I've renamed it to Algae Brew because that's what that project's all about. We have a bunch of papers on this topic already because people have done a lot of research, a lot of it coming out of India as well.
Oh, yeah.
Yeah.
Tremendous amount of work being done there.
Yeah.
Really fantastic work.
India and China are working very hard this decade.
Baker.
I mean, they were hard hit by the smog, like the smog created by non-catalytic conversion, and also like just the whole like, the sheer amount of population. Yeah.
I shared a video on a geology channel. Like China will get flooded, like billions of people will have to move.
And yet China and India are doing their best to kill each other.
Yeah,
I mean, to be fair, everybody's doing their best to kill each other. So, you know. Glass houses there, bro.
Well, it really does seem like China and India are trying to really invest in their infrastructure in the ways that other European countries and America are not, though. So props to that.
China
Right.
doesn't have the bullshit of hardcore politics. Like the moment they decide that they want to go solar, they'll just invest a crap ton of money. Right now, they're not bad.
Left turn at Albuquerque while I have a moment, and while I've got a lot of people here. Heard the phrase, I have no idea what that is in Fahrenheit earlier. I want to remind everybody that we have a bot that actually does those conversions live, among many other utilities. Tav, I'll let you take over there.
We should
I'm
just
right.
stop.
I'm basically writing the script for that
Oh,
bot,
I
and
can
Zip
hear you
Digital
now.
is the one hosting. He's the one hosting that bot, so it runs 24/7. So it's like me and Zip. We're ensuring that the science helper always functions and functions well. So if you want to convert, like for example, Fahrenheit to Celsius, you just like exclamation mark F2C. Preferably in a private chat. You can private chat the bot and you just use it as your personal little Wolfram alpha kind of thing.
I did not know that.
Ollie,
Yes.
I haven't got a question, but I've got some food for thought here. Having heard your the talk, it sounds like even if this isn't ending up being perfect, it sounds like you've got a solution to what is what they call at work the van problem. All the which I could describe it as you can have electric vehicles and all sorts of alternative sources of energy for vehicles, but when you're stuck in the middle of nowhere with a van and you can't, there's no charging port or anything, and all you can get is a jerry can of fuel, it makes the difference.
Hmm.
Yeah, we already have the infrastructure to send back and forth combustibles
Yeah.
in liquid form.
For dealing with long distance, out of reach, hard to get areas like mountains, farms, agriculture, not
Yeah.
inner city stuff.
You could have your own.
Well, you're insinuating a car that does both gasoline and battery. Am I understanding that correctly?
Hybrids.
Hybrids are pretty common.
Yeah.
Okay, just making sure I'm understanding what we're talking about.
Well, it could just be a pure
Hybrids
diesel
seem to be
car.
very rare.
But yeah, no,
I did come to the party late. I apologize.
that's fine. No, that for rural communities, this would work beautifully because this wouldn't be too hard to just set up mini refineries for those areas that are also growing the algae. And you can sort of decentralize from everything. You don't have to pay transport costs to be moving everything around, and which obviously is even more carbon emissions.
Right. I believe that the trickiest part is to have the supercritical carbon dioxide chamber. But yeah.
Yeah, that's the
So
common way.
So I see this research as generally a carrot and the stick type of research. Which means that there's like a thing that we really shouldn't be doing. We should be having like more sustainable communities. We should, if the problem is combustion, finding like the best way to set things on fire is not actually the best solution, but it's a good solution which allows people to focus on other things. So I think you mentioned that there's like this can also be used as feedstock, and this can also be used as actually like mixed with, and there's a whole bunch of other things that this can be applied to.
Yeah.
This is just the shit that gets the grant money. So it's not necessarily when you look at a paper and it's talking about biodiesel, it's not necessarily about making happier cars. It's about creating a larger infrastructure of sustainability, but there's words that you have to use so that people give you money.
Yeah.
Does that sound? Does that like hit a nail on some head somewhere?
That's,
But I mean, I hear what you're saying, but I don't get exactly how it fits in here.
what do
like-
you mean?
So like we need to like try to incentivize funding for these kinds of papers, and like essentially what you're saying is like you want to try to incentivize funding that's like actually kind of like tangential to the research is kind of what I'm hearing. Like it's not actually the core of like the research, right? Like it's just that this plugs into
Stepping
like
stone, I guess.
this
So
plugs
this
into
is a
like
this is
the
a
vernacular
core
people
this is
use
a
it to.
core paper, right? So
Okay.
there's been a lot of work that's been done with this thing. Most of that work is not necessarily about making gasoline, but you
Right.
need money to do research. And so so for instance, I did work on sterilization of endospores, like basically
Okay.
just like making things sterile at room temperature in a non-hostile environment. It was like kind of like chemical bacterial whispering. You just kind of said the right things. But the point is, the only thing that anyone cared about who was going to give you grant money was about like making sure that anthrax
Yeah.
or something
Cancer.
wasn't
This is
a
for
thing.
cancer.
Yeah, this is for cancer.
This helps.
So, yeah,
Yeah.
exactly. And so that's why they gave us the money, but the research itself was actually strongly towards the medical field that could be applied in developing nations. But the only money that we got was from the NIH, and actually DARPA gave us the most amount of money because we just threw the word anthrax in there because anthrax
Nice.
also makes endospores. And but so you need to think about the big game, the meta game. Like sometimes these papers are not just about making gasoline. They're about how do you say now we have quantified all of the different ways that you can measure turning pond scum into full. And because the only thing you care about is gasoline, we're going to talk about gasoline. But we did all the math for everything.
Yeah.
And so that's there. And so people can use that.
Yeah.
And one of the things that we need to do as researchers is to see the things that aren't being talked about. Because now the math is there, and that's good. It's valid and inherently worthwhile, independently of the purpose that was given by the funding.
Gotcha. That makes sense.
Yeah.
Can confirm some of the organophosphonates I work with in the lab, they also have like bioweapon applications. And so we get a lot of funding from DARPA and things like that too, because it all feeds into itself.
Yeah, I hear that. That makes sense. Like I was looking at doing some artificial muscle like exoskeleton stuff, but like the moment you mention like exoskeletons, it's like, oh, now this qualifies for like government grants because like now the military or whatever is involved.
Okay. Anyone else got any questions, or or is it actually going to be a really quick journal club?
No, enough politics. You said you were going to get back to it. Let's do more journal.
Give us the good stuff. We came for the good stuff.
Okay. What particular things do people want to know about from the paper then?
What was the consumption, if at all, of ethanol that was measured? Was it stable?
The consumption of ethanol was, they gave it 258 grams per ton of biofuel they wanted to produce. And I believe they only lost a few percentage. You had to jump around the paper to try and find it. I'm
Yeah.
trying to see where it was.
I'm looking around and seeing many numbers that I don't know what they actually like.
Yeah.
Can you go through these images, like these organograms? Not the organograms, like these input output diagrams.
Yeah,
can you go
sure.
through them?
So it's logically starting at figure 1. And figure 1 is just showing the cycle between having the CO2, creating the algae, to the biofuel, to burning it to produce the more CO2 to go back in. And it describes it as having only the energy input of solar, as we would expect, because it's growing it. And then the waste is almost entirely done through, almost all of it is wasted off as heat. with 0.27% of the total, no, 27% of the total energy comes out as useful work. It doesn't give the numbers there, but you get the numbers all the way from the conclusion. And most of the wasted energy comes out during the biodiesel production stage. And all of the restorative work, so to revert the environment back to the state before you started doing anything, is actually done through the whole production phase. So they don't have to put any energy through that, which is shown by the blue arrow coming out of diesel engine going into algal biomass and biodiesel production.
I have a question.
Yes.
I know that this is one of the more efficient means of extraction of the lipids, but have you done a review of less yield processes that and whether they are the lower yield you get will counteract the lower yield you get is counteracted by the extraction method being more efficient for energy input and or long-term sustainability of that process.
On this one, they actually did the lowest energy process they could muster to get the lipids out, which is you leave the algae floating in the solvent for a long time, which is very low energy, and I believe it extracts, from other papers, I remember it's somewhere around 60 to 75% of lipids. They don't talk about the percentage of lipids extracted in this paper, because that's not the concern for rating the thermodynamics of it. Things like CO2 supercritical CO2 specifically, to extract lipids will take a lot more energy. Just because you are having to heat it up and cool it down, and constantly to be cycling in to get the algae in and then get the lipids back out and put more algae in and get the lipids back out, which I don't have numbers for it, but I would imagine that would lower the thermodynamic efficiency of the system.
So question slash statement again.
Okay.
So
is that
what I'm trying to get at is that how do you know that this which process overall produces the most biofuel for the input energy, regardless of the yield? Because that is if you lose a lot of your ethanol for a smaller benefiting yield, wouldn't that be less in a hypothetical universe and be less efficient than using a process that doesn't use a consumable resource but has a lower yield?
Okay. So the ethanol in this paper, none was lost in the extraction of lipids. It was all lost as part of the processing for the biofuel, and the ethanol is not a catalyst; it's actually used up to produce the biofuel, so it's not an avoidable loss in that reaction.
You're saying that the ethanol cannot be not lost. So for the extraction, so right, I'll rephrase the question. So moving towards the processing of the biodiesel, that you're saying that the ethanol is needed for that, and there's no means apart from the catalyst being suspended in that solution.
You could
solvent.
You could change the solvent, and different solvents will go through the process differently. But to get the maximum conversion of lipids to biofuel, they were using an alcohol, because the alcohol will react to produce slightly more biofuel.
It looks like paper that reference 32 in this paper actually digs into that exact question, Alex.
Right.
Okay. Because it'll be worth looking at that if you're producing an end product. You'll have to deal with reality at some point and the system as a whole will have to function to some varying degree. But if because
are we getting back to the conversation about how you can't break the laws of thermodynamics?
Yeah.
Gabe, you said you had a statement.
Yeah. So the TLDR of what you were trying to say is the easiest way to do this is to put it in a puddle and let it sit for a long time, right?
Yeah, pretty much. It's the
Yeah.
lowest energy input extraction method you can do.
Right, especially because your primary source of energy coming in is the giant thermonuclear reactor that crosses our sky every once in a while. And your primary source of carbon is us all exhaling, correct?
They were actually putting in a pressurized form of carbon from a chemical reaction for the purpose.
Extracting it.
Yeah, for the purpose of the paper. But if it was used in the real world,
Right.
you would be using the
But
atmospheric
in
carbon.
the real world, like to talk about what Alex was trying to talk about here, it's like, what is the most efficient thing? It's being really, really fucking patient.
Yeah.
Right? I mean, am I just like shorthanding this too hard, or does that make sense?
And also perhaps draw similarities on how worse the other ways of converting it is. Like you have gasification and pyrolysis, which is like absolute trash compared to this. This is like super clean compared to the methods we have currently like applied and yeah.
So Bass mentioned, what was it, 32? Reference 32. Can somebody do me a favor and go and dig up that paper really fast and throw it in so that we just have that? Because it is specifically talking about what Alex was curious about.
Yeah.
And this kind of cost benefit analysis thing, as far as I know.
Integrated biodiesel production, a comparison of different homogeneous catalyst systems.
Yeah, let's get granular with this shit, yo.
I have a question.
Yeah.
So in the real world, where does the CO2 come from?
The atmosphere. These are
Okay.
like, you actually have algae farms that are built, and they are normally built either near airfields or outside standard fossil fuel generators. So they're just taking the carbon before it diffuses too much into the atmosphere.
So it doesn't have to be like concentrated, like they have
No,
it.
they did that just to make the algae grow quicker.
Okay.
Would it
I mean,
benefit if it
even
was artificially maintained?
even the concept of gravity is actually granular and changes depending on where you're at. So, like, yeah, the fact that they put these things next to airfields makes a lot of sense. We think of the atmosphere as being the same all the places all the time. But if anybody's gone on a road trip next to a cow farm, you know that the air tastes different. And therefore, air is not the same every place that you're at. And so, in the same way that we will go to certain locations to harvest materials, carbon in the atmosphere is also location based and a material that we can harvest. Does that make
You're giving me
sense?
some bad memories of when I lived next to a paper mill.
Okay.
I got a question.
Yeah, all of the Pacific Northwest feelings right there. Tacoma.
Okay.
But did
I
that
got-
answer the question?
Someone got a question.
Someone
My
had a question. I
was-
tried to answer it.
My question was, would it benefit from being artificially maintained, the air?
Oh yeah. Well,
No, because no, it wouldn't, because then you have to put energy
Interesting, we got a
into the
50-50
system.
split here.
you'd have to measure it and actually work out whether it gives you an increase or a decrease. If we are not considering the energy input, it will give you more yield of biofuel.
Right, but that's not going to actually do the thing. Basically, you're just doing the most green-washed version of capitalism ever, where you're not actually considering the energy put into the system. You're only considering your output. The answer is almost always the laziest option.
So, for your project, what are you doing right now for?
I
for this
am
project?
reading a ton of papers and learning as much of this as I can.
And if other people are interested in this project, you should also, like, there's a folder. It's in the to be sorted, right, Ollie?
Yep, and I'm just about to add
Yep.
the reference 32 to it now.
Yep. Find your little unique rabbit hole. There are so many rabbits here. Every single one of you can find your own personal rabbit hole, and you can learn a whole bunch about the metabolic processes of pond scum, which sounds
And
so silly when you put it that way, but it's
Yeah.
actually really freaking cool. And if you don't know about it and you wanted to help, you wouldn't be able to help very well. So step one is read a bunch. And come to Journal Club and even present in Journal Club, though I've totally taken over December. Sorry, everyone.